Hey y'all, in this video we're going to talk about circles. We're going to start off by reviewing some words you probably already know and work our way towards words that you may not be as familiar with. So let's start off with the obvious, the definition of a circle. And you may notice I'm holding a compass, and because we have worked with this compass, we know what a circle is intuitively, right? It is a set of all points in a plane that are the same distance away from a given point on the plane, right? The way compasses work, we take the stabby end, poke it into our paper, and then we have the pencil end, and we set some distance between the pointy and the pencil end, and we rotate it, and we create this shape where every single point on this shape is the same distance away from this point A, right? That is what a circle is. We know what that is. Now, of course, we name circles by their center. It's a point, so it's going to be a dot with a capital letter attached to it. And if I want to name this circle, I would name it Circle A. And the geometry abbreviation of circle is literally to draw a tiny circle with a dot in it and the capital letter that is the center. So Circle A. Now, the distance that we're talking about, you know as the radius, right? It is the distance that this point is away from all of these points. Now, in geometry, radius plays two roles. It could be the distance, or it could actually be the physical line segment itself. So we define radius as the segment of a circle, right, where one endpoint of the segment is the center of the circle and the other endpoint is on the circle. This is radius. It's also the distance. So depending on context, I might be talking about the segment or I might be talking about the length. Now, another word you are used to being a distance is diameter. You know diameter as being twice the radius, right? But in geometry, it's a line segment, specifically one that contains the center with endpoints on the circle itself. Okay, so diameter can be the distance of two radii, or it could be this line segment, goes to the center, endpoints on the circle. Now, of course, we only have circles that are congruent if they have the exact same radius. Makes sense? And concentric circles are two or more coplanar circles with the exact same center, often drawn as like a little dartboard or target. So now let's move on to a word you may be less familiar with, but is going to be super important in trigonometry, and this is the word arc. So the arc of a circle is just basically a part of the circle, but it's defined as the 2 points on a circle and the continuous part of the circle between those 2 points, okay? So my 2 points are A and B, and I'm looking at this piece of the circle right here between A and B. And this definition may sound familiar because it's very similar to the definition of a line segment, right? Line segment is 2 points on a line and all the points in between those 2 points on the line, right? Arc of a circle, same thing. 2 points on the circle, all the points on the circle that are between those 2 points, okay? And of course, we have an abbreviation for arc. We use, in this case, these two letters A and B, and instead of drawing like a little line segment across it, we draw a little arc above A and B. And of course, we can switch A and B, or we can name it BA. And of course, it's not enough to have arcs. We have to have different types of arcs. We're going to start off with the definition of semicircle, which is essentially half a circle, right? It's the arc where the endpoints are a diameter of the circle, right? That's a semicircle. And we need that to define these other two arcs. A minor arc is the arc, and any arc that is smaller than a semicircle, and a major arc is any arc that is larger than a semicircle. So here I have drawn a circle with 3 points on it, A, B, and C. And I know that A and B is a minor arc, okay? Now, the rest of the circle is a major arc, right? It's bigger, it's definitely bigger than a semicircle. Now, I don't want to confuse the naming, so we only use 2 letters for minor arcs, okay? A major arc or a semicircle needs 3 points. Its endpoint, some middle point on the arc, other endpoint. So the major arc in this case is going to be named A, C, B. Endpoint A, point C on the arc, other endpoint B. And that's how we distinguish the minor arc from the major arc, is by the number of letters we use to name them. Now here comes the part that might be a little confusing at first. Arcs have measures and they have lengths. and they are two completely different things, okay? A measure of an arc is always given in degrees, okay? So a full circle is 360 degrees. A semicircle, its measure is 180 degrees, and we define these measures by something called a central angle. A central angle is any angle with a vertex at the center of the circle, and the sides of the angle pass through points on the circle. Okay, so this ACB is a central angle. And this is how we define the measure of an arc. The measure of the arc is the exact same as the measure of the central angle that cuts the arc. So I say arc AB is cut by angle ACB. ACB is a central angle of 30 degrees. Therefore, the measure of arc AB is 30 degrees. And this is to be contrasted with the arc length. An arc length is a distance from endpoint to endpoint, and it's always going to be some fraction of the circumference of the circle. So if I have a circle here, radius 1, diameter 2 units, right, and I have a central angle marked a 90-degree angle, I know the circumference of the circle, or the distance around the circle, is 2 pi units, right? So that means the length of AB is going to be a fraction of 2 pi. Since I have a 90-degree angle, its fraction happens to be 1/4. So the arc length is pi over 2 units. It's a distance, not an angle measure, okay? We're not going to focus on arc length right now. In our circles unit, we're going to start our focus on the measure, and then we're going to move on to arc length later. And this is going to be super, super, super important in trigonometry. Now let's move away from arcs and talk about something called a chord. And a chord is a line segment with endpoints on a circle. So AB is considered a chord, right? Now chords can go through the center, and so we can think of the diameter as a special chord of the circle that passes through the center of the circle, and it is always the longest chord. And then we move on to the tangent. Okay, this is an example of a math word used differently in different contexts in different branches of mathematics. So right now, tangent is going to be a line that intersects a circle exactly once. Okay, so when I draw this tangent, I say this is a tangent to the circle. It only hits the circle in one point, and that point is called the point of tangency. So if I have this here, I would describe this drawing as line 1 as being tangent to circle C at point T. Now this contrasts with the word secant, another word that's going to have a different meaning later on. Right now in geometry, a secant is a line that intersects a circle at two distinct points. And you'll notice that the secant creates a chord, right? But it keeps going, right? So line 2 is a secant of circle C. And our final vocab related to circle is something called an inscribed angle. And an inscribed angle is an angle with its vertex on the circle, and the sides of the angles are chords. Okay, so this is in contrast to the central angle, which has its vertex at the center. An inscribed angle has its vertex on the circle itself. So angle BAD is an inscribed angle of circle C. Now, one thing that we talk about is angles intercepting arcs. So DB, this arc, is intercepted by this angle DAB. It's basically, it means the angle cuts that little arc of the circle. That's what intercepted arcs are. And that does it for our circle vocabulary.